Network design is an iterative process that includes topological design, network synthesis, and network realization. Its goal is to ensure that a new telecommunications network or service meets the needs of both the subscriber and the operator. Topology, layout, diagram, and map are some of the many terms used to describe basic design. A network's topology refers not only to the physical layout of its computers, cables, and other resources, but also how those components communicate with each other. When designing a network, you must have a firm grasp on its topology's uses, as well as their limitations. A solid design grows and adapts the networks as needs change, whereas a poor design limits growth potential and must eventually be replaced. This is why your design should provide room for growth and meet your defined security requirements. All networks designs in use today are based on three topologies, which are the bus, star, and ring. Bus, or also known as linear bus, is the most common method for connecting computers. All the components of the bus topology connect via a backbone, a single cable segment that theoretically interconnects all the computers in a straight line. To understand bus communications, you must be familiar with how a signal is sent, how the signal bounces, and cable termination. Sending the signal. In a bus environment, only one computer at a time can send information. Therefore, all network users must share the available amount of transmission. The more computers that are ready to send the data at the same time, the longer some computers must wait to send their data. This slows down overall network performance. Bus topology is a passive topology, means that computer on the bus only listen for data being sent. They are not responsible for moving data from one computer to the next. If one computer fails, it has no effect on the rest of the network. Single bounce. As a signal travels across the network medium, it moves from one point of transmission to both ends of any bus. If allowed to continue unchecked, such a signal would travel across the network continuously, bouncing back and forth, preventing other computers from sending data. Cable termination. A terminator attached to each end of cable prevents signals from bouncing. This terminator absorbs all signals that reach it, thus clearing the network for new communications. Cable failure. A cable break in a bus network occurs when the cable is physically cut, or one end becomes disconnected. Because of the cable break, the cable is no longer terminated and this causes signals to bounce. Star topology. It is described as computers connected by cable segments to a central hub. When a computer sends a signal, the hub receives and retransmits it down every other cable segment to all other computers or other devices attached to that hub. One benefit of star topology is its inherent centralization of resources. Drawbacks of using star topology include it requires a more intricate cable installation. The hub defines a single central point of failure. If a hub fails, all other computers and devices attached to that hub lose network access. So the advantage of using star topology is that the relative ease of troubleshooting. Ring topology. When each computer connects directly to the next computer in line, a circle of cables form to create a ring topology network. As a computer receives a signal, it either acts on it or regenerates it and passes it along. Signals travel in only one direction around the ring. Token passing is one method for sending data around a ring. A token is a small packet, passes around the ring to each computer in turn. If a computer has the information to send, it modifies the token, adds address information in the data, and sends it around the ring. That information travels around the ring until it either reaches its destination or returns to the sender. When the intended destination computer receives the information, it returns a message to the sender to acknowledge its safe arrival. The sender creates a new token and sends it around the ring. So the advantage of using the ring topology is that the ability to share networks resource fairly, and the disadvantage of using ring topology is that a single ring network can fail if one computer in the ring fails. Wireless networks eliminate the need for a visible physical topology. wireless networking have a topology associated with it. Two computers can communicate directly with one another in a peer-to-peer topology, or sometimes called an ad hoc topology. Hubs. So there are two types of hubs, which is the active and passive. Active hubs regenerate or repeat the signals as they receive them and send them along. Multi-port repeaters is a device that takes a signal coming in one port, cleans the signal by filtering out noises and other undesired information, strengthens the signals by regenerating it to original signal levels, and then sends the regenerated signal out all the other ports. In a passive hub, such as patch panel or punch-down block, the signal passes through the hub without any amplification or regeneration. Passive hubs are used as junction points between a long-run cable and between short runs of cable. Hybrid hub is another hub that used to interconnect different cables. So hybrid hubs help maximize the network's efficiency, interconnect different topologies, and thus realize the benefits of combining network topologies. Switches. A switch is like a hub, is the central connecting point in a star topology network. Unlike hubs that simply regenerating an incoming signal and repeating that signal out all other ports, switch actually determines to which port the destination device is connected and forward the message to only that port. So there are four variations or combinations of the major networks, which is the extended star, mesh, star bus, and star ring. Extended star topology is a stars of stars. A central device, usually a switch, sits in the middle of the topology, and rather than attach computers forming the arms of the stars, other switches or hubs are connected to the ports of the central switch. Computers and peripherals are then attached to these switches or hubs, forming additional stars. Mesh topology. A mesh topology is used in a wide area networking to ensure that all sites remain able to communicate even in the event of a cable failure. Internet is one of the examples of mesh, but not the entire internet, but the critical pathways are, providing fault tolerance to the key junction points. Star bus topology. A star bus topology is implemented when a bus backbone interconnects two or more hubs. The star configuration minimizes the effect of any single computer's failure on the network. Star ring topology. A network that is wired as a star but that handles network traffic like ring. So here are some advantage and disadvantage summary of each topology.